the coming software apocalypse. Today's topic on the RTC live stream. How's everyone doing on this beautiful Wednesday afternoon or evening or early morning Thursday to my international peeps? Ooh, day, I don't know what, of quarantine in the States, at least in my area. Quarantine at RTC headquarters until further notice. Hope everyone's doing well out there. We have a very interesting topic today. It's about the coming software apocalypse. Today's topic is based on an article sent to me by one of my patrons, GTD. Number one, I want to say thank you to people like GTD who support this channel financially and make these videos possible via Patreon. Sammy, I already saw her checking in. She's a patron. Janos, all the peeps. We have some great people supporting the channel on patreon.com/RealToughCandy, as well as some people supporting it via the YouTube channel membership option. There's some perks available for each of those platforms. If you are available to support the channel at this time, if you're not, that is totally okay. Please just pop in a like, tell a friend, and we can keep producing these live streams and these videos. Now, the second thing I want to say about this topic is that this is a type of topic that has traditionally not performed very well on my channel. Where we talk about less about the implementation, less about the heavy tech, and less about the hot new frameworks. This is the type of thing that incorporates society and really makes us think from a policy standpoint, from a social standpoint, from thinking into the future, all different things to talk about. This type of video does not perform well on my channel, and it is because, you see the tie-in? It is because of people like GTD and my patrons who make these, especially these types of videos possible. Because if I didn't have the financial support with them, I simply would not be having an incentive to make these videos. And I just love these topics. So, thank you. We're going to do a roll call. Everyone knows by now, Janos, Sammy, Paradoodly-Doo, the guy from Cameroon, I've forgotten your name already, but I'll check in a second. I appreciate you tuning in from all walks of life. This would not be a complete stream without a total and unabashed product placement. We have mugs, we have stickers, we have t-shirts, we have hoodies. Oh yeah. We have leotards. We have pillows. We have socks. If you're wondering how on earth you could spend your money in a frivolous manner, check out the Candy Script Teespring store. Paradoodly-Doo is going to be an awesome mod and pop that link into the chat box for your entertainment purposes. So, let's do a roll call. And then we're going to get to talking about this topic. Again, today's topic is based on this article, but we're going to talk about all sorts of stuff. We're even going to talk about this thing called TLA Plus, which was referenced in this article. It's I don't want to say esoteric. It's not, but it's a pretty not well-known language that got some love in this article. So how we could explore that could be kind of fun from a software perspective. But let's prioritize here. Let's go see who else is in the chat. Rebecca! Hello from Springfield, Illinois, a fellow Midwesterner checking in. How's it going, Rebecca? Thanks for tuning in. Sarah A, Sarah O. I almost said Sarah H. I'm like, who's Sarah H? Sarah O, our other awesome mod here on the tube. She's also a great moderator over on the Discord. We have almost 1,000 people there, and it is such a fun group. Today, we were talking about manatees, jobs, code, you know, the huge. Check out the Discord. Paradoodly or Sarah, you mods know what to do. Pop that Discord link. Let's see. Christian's the one from Cameroon. Thanks for tuning in, Christian. Pavel, how's it going? Candace, Dr. Candace is checking in. Hello, hello. Dennis Ecknauer, greetings from Ecuador. Thank you for your suggestion on Newbies, intermediate books for web developers. You're certainly welcome. I'm glad it helped. Main Street Studio? Main Street. Paradoodly-Doo told me you have an interview coming up. Is this true? Is this a thing? I'm happy for you. I hope you do well on it, and I'm wishing you the best of luck in your interview. Matacoma Blessed, welcome back. Randy Miller, a YouTube channel supporter. Hello, hello, Tech Rally. What's going on? Great to see so many people already in the chat. This is awesome. Okay, enough of my babbling. Let's talk about the topic. There is just so much to talk about today, and I hope GTD, the person who showed me this article, can show up too and add his or her 2 cents on this, or maybe even more sense. Make some sense out of this 2 cents. So basically, this is a very long article, and for those of you who want to follow along, I'm going to post this in the chat in just a second here. But for those of you who aren't familiar with The Atlantic, it's a consumer level. It used to be a magazine. I don't know if they just do online. It's been around forever. And they do these. I myself, I just have to be honest here. I myself am not a huge Atlantic fan, but sometimes their articles can be really engaging. This is one of them. And basically, this is a 10,000 word article, all right? So I'm going to try and summarize it without sounding like a total rube. Basically, the article chronicles failures of software in the recent years, such as the Toyota's unintended acceleration problem, such as Washington State's complete 911 blackout for 6 hours. I think that was in 2014. And there are a few other ones referenced here, but those are the 2 biggies. But we have seen some things, even I remember just nonchalantly passive listening to news over the past couple years when I'm out and about, because like, what's with airports playing CNN? Like, what's with like restaurants and these different places playing CNN? I don't get it. But anyway, so I'm like doing my thing and hearing these news stories. There have been places in the States where the 911 grid, or like the emergency broadcast system, had been somehow deactivated by a software glitch. And I think it has happened a few times where the tornado warnings around the states have not gone off due to a software glitch. So the article starts with that as a hook, just kind of establishing how software is now everywhere, even in these critical systems, especially in these critical systems. We could even do stuff like healthcare. There's a radiation machine that runs on software like everything else in the world. A couple years ago, or I don't know when, probably within the last 10 years, I'd say, it killed a few people because of a bug in the software. I don't know how. In classic mainstream media format, I have no context. But according to that article, it was a glitch or a bug that caused these people to pass away. So that's where this article is coming from, and then setting up the scene in the near future of how we are really facing a software apocalypse in these critical industries, and perhaps by proxy non-critical industries, because software is becoming more unmaintainable. It is being built upon in an unprecedented way, and what happens when that happens? Spaghetti code. And developers don't know what really is happening. So we're going to talk more about this, because this is not just happening in mission critical industries like, I don't know, military avionics. There are so many industries that are critical. Even non-critical industries. They're critical to us if our paycheck depends on them. So let me pop this article. This is my introduction. Let me pop this article. If you want to follow along to this, we are looking at the Atlantic article. So I actually took some notes here. Okay. Let's see, where do I even want to start with this? Okay, so let's talk about the first thing in this article about what do they call it? Unintended acceleration of the Toyotas. You guys remember that? It was like, what, like 13 years ago or something? It was like 2007, 2009-ish, late 2000s. These Toyotas were accelerating by themselves. And as you can imagine, some not so good things happened when that happened. People were maimed, people were injured, people were killed. And the first round, Toyota was like, you know, it could have been driver error. It was probably driver error. And they had NASA inspect the code base for the Toyota to see where they could find the critical flaw in these controllers and these computers, and the actual just line by line going through it. NASA engineers could not pinpoint the problem with unintended acceleration. So, you know, a lot of people were still suspicious of that. So, let me check my notes again because I don't want to misspeak on this. Okay, so a different firm, we'll say, it was a research firm, took the case back on. They spent months, I think they spent over a year looking through this code, and they found it. They found the code they found the processes delivered by this code, created by this code, that caused the unintended acceleration. And so therefore it was in the end deemed a Toyota responsibility and also the problem of code. And as we are getting more and more into these critical industries, self-driving cars, even non-self-driving cars, cars, anything, any model built nowadays, most models, if not all of them, have millions of lines of code in them. That's done by software engineers and developers. What's it going to look like in 5 years, 10 years, when these code bases are so gigantic and we can't control them? And that was really the premise of this article. So it goes on to talk about these different things. And one of the interesting things here was, actually, you know what? I want to give you this example of this 911 thing. You guys are going to find this interesting. Listen, because this has happened to all of us. This has happened to all of us as software developers. The only difference is that it is in a critical industry. It was the 911 blackout in Washington State. Let's see, this is a 10,000 word article. It's going to be hard for me to find things on demand. Let's see. Okay, here it is. So, let me read this. There were 6 hours during the night of April 10th, 2014, when the entire population of Washington State had no 911 service. People who called for help got a busy signal. One Seattle woman dialed 911 at least 37 times while a stranger was trying to break into her house. When he finally crawled into her living room through a window, she picked up a kitchen knife. The man fled. The 911 outage, at the time the largest ever reported, was traced to software running on a server in Englewood, Colorado. Operated by a systems provider named Intrado, the server kept a running counter of how many calls it had routed to 911 dispatchers around the country. Intrado programmers had set a threshold for how high the counter could go. They picked a number in the millions. Shortly before midnight on April 10th, the counter exceeded that number, resulting in chaos. Because the counter was used to generate a unique identifier for each call, new calls were rejected. And because the programmers hadn't anticipated the problem, they hadn't created alarms to call attention to it, nobody knew what was happening. Dispatch centers in Washington, California, Florida, the Carolinas, and Minnesota, serving 11 million Americans, struggled to make sense of reports that callers were getting busy signals. It took until the morning to realize that Intrado software in Englewood was responsible and that the fix was to change a single number. Developers, this is the kind of stuff we do all the time in our projects. If we're doing this for a digital agency, for Lucinda's dating landing site, her landing page for finding a man, it's not that big a deal. You just go in, change the number, hope that you didn't miss out on a date, and get on with your life. But when it comes to something like this, lives are on the line. A chaos is imminent, and there's so much on it. The stakes are so high. So, like, But how can you anticipate every single possible outlier or every possible scenario? Humans are so dynamic and crazy and unpredictable that no code, as far as we have gone this far in the collective coding journey, no code can account for all of those variations. Not yet, anyway. And furthermore, no code has been able to respond with alacrity, if that's the correct word, with that elasticity. Even if we write code that has a safety valve, sometimes that safety valve isn't working, or it doesn't respond as quickly. Now, one thing that was not mentioned, this is what I want to emphasize, though. When you are working at your job, we don't need to have a certificate. We don't need to have a license to code. We don't need to have any sort of green light from a government agency for the most part. If we're working for a government agency, then yes, we usually need to have a secret or top secret clearance, depending on the department you're contracting with or working for. But stuff like this, they probably didn't need to have any sort of clearance or anything, nor should they. I mean, right? Like, what is the argument for having some sort of certification for doing this? They probably wouldn't have anticipated that problem anyway. There's always going to be a problem that isn't anticipated when we're coding these things and when we're planning. Now, in this article, there were a few things that I smelled BS on this article. For the most part, I thought it was really well written. But this is not a literary critique. I would just like to point out that this person said that Visual Studio is used by nearly 1/3 of all professional programmers. I call BS. Let's see, Visual Studio. So he was saying Visual Studio is an IDE that costs $11.99 a year. That's true if you opt for like the enterprise version. It's free if you're using it for personal or small projects. Is used by nearly 1/3 of all professional programmers. I call BS. But this was interesting too. So this journalist interviewed one of the developers, the lead developer for Visual Studio. Not VS Code, but Visual Studio, what you use to work with .NET and C# and stuff. So this person who was the lead developer on that, it says he arranged an end-to-end study of Visual Studio. For a month and a half, he watched behind a one-way mirror as people wrote code. How do they use tools? How do they think? How do they sit at the computer? How do they touch the mouse? Do they not touch the mouse? All these things that we have dogma around that we haven't actually tested empirically. So what he's saying is, he was designing these programs. He was designing Visual Studio without really knowing how the users were acting. That was an interesting thing. So he's decided to do this empirical study. Empirical just means getting your own data, doing the work and gathering your own data. Visual Studio, this is what he was saying about his findings. Visual Studio is one of the single largest pieces of software in the world. It's over 55 million lines of code. That's a lot. And one of the things that I found out in this study is more than 98% of it is completely irrelevant. All of this work had been put into this thing, but it missed the fundamental problems that people faced. And the biggest one that I took away from it was that basically people are playing computer inside their head. Programmers were like chess players trying to play with the blindfold on. So much of their mental energy is spent just trying to picture where the pieces are that there's hardly any left over to think about the game itself. That's a powerful observation. And it really illustrates a few different things. Number one, the importance of architecting, the importance of planning. Now, no doubt, something like Visual Studio took a team of people, and no doubt they sat down and planned. But so many times, you'll find this more often than not. It's just the standard, and it's just the way businesses are. The deadlines take priority over quality code 100 times out of 100. Ask anyone. Ask Vlaslo. Ask anyone in this chat who has been or is currently employed in the software development industry. The deadline takes priority 100% of the time. Whether or not the code is good, whether or not the code is an absolute disaster, as long as it works and fulfills the basic requirements, that's what the stakeholders are looking for. And unfortunately, this really hasn't been mentioned in this article, but whether you're working in a critical industry or not, because we live in a for-profit society, we have to pump out these programs. People are very impatient. There are deadlines, and because people outside of our industry do not understand how this stuff works. They think it's voodoo, and if you've ever freelanced before, you know exactly what I'm talking about. Well, can't you just add a completely new database? It shouldn't take that long, right? Like adding 50 add to cart buttons on one picture actually makes good sense, and it shouldn't take that long. It's not outlandish. By the way, I need that landing page to be burnt sienna and toxic orange combined with Minecraft green. Like people just don't know, because we've talked about this on a different stream. Because using the internet is so easy, and because these things have been finessed over the decades, getting on a computer and using it is totally non-cerebral. So people think it's easy for us to do these things. They have a bias. And it's not a terrible thing. It's not like, well, they're awful people. Like, that's just how people think. When you hear a really good guitar solo, it looks effortless. But that person practices guitar like a full-time job. You will never see it. You will never see them practicing. But before they get on stage, they had spent years perfecting their craft. And after they get off stage, a lot of musicians are still playing and practicing and writing new stuff and improving themselves. People don't see our processes, so they think it's really easy. They just see the final product, which is really silky. So we have these external factors pushing on us. We have these external pressures, whether you're at a digital agency or working for a government agency, working for a 911 grid somewhere. There are a lot of stakeholders out there who do not respect our craft. Furthermore, we have totally abstracted away from computing as being a mathematical process. And even as someone who tends to shy away from calculus, trigonometry, and all this crazy mathematical stuff, computing is applied mathematics. And unless people have years of experience with mathematics, there's a reason people at Google writing these algorithms hold PhDs in mathematics. If they don't hold a PhD in computer science, they certainly hold a PhD in mathematics. And those are the people at the top, working on these proprietary algorithms. And they're the ones to even say, we don't even know how they work. So that's getting back to this issue of the coming software apocalypse. Because as we're building these more robust programs, and you know what? Centralizing too. We're doing a lot of centralization. And that, I think, is going to really catch up with us too. That's not talked about in this article. But you don't just see it in software. This is just a trend everywhere, the centralization of services. Things are going to be clashing. There's going to be more stakeholders. There's going to be more pressure. And there's going to be more code because we're trying to make things more of a conglomerate nature. Picking these different services and just mashing them and making, as a result, code that is not only spaghetti code, it's unmaintainable code, and we don't know what's inside of it. And so we're seeing little hints of this. We're seeing hints of this. And, you know, I'm the first one to be like, I don't trust the media, because I don't. I have a lifelong interest in media studies. It wasn't a recent revelation. This has been going on for years. But you know, I realize that The Atlantic has magazines to sell and ad space to sell. So reading this, I did come in with some skepticism, but I think it does bring up some good points. But there are also some points that weren't addressed. So that's kind of what we're talking about today, too, with this thing. Let's go to the comments and see what people are saying about this article. Technomancer, what is up? Andrew, how's it going? Joaquin. King, what's going on? GTD's here, welcome. George Meehan Dev, welcome, welcome. Thanks for tuning in. Sammy Turner says, about Visual Studio, I think maybe a third of all devs have it on their machines or have used it. I have it on mine, but I haven't touched it for a while now. I'm curious where they got this. Is me just being a software developer looking out for the industry in some weird like nanny way. I'm like, I don't know. I'm just being nitpicky with that. But you know, as a developer, that's something that popped out to me. It's obvious. I am absolutely not trying to distract from the article. It's just something that I noticed. Andrew Weller, we pretend we'll refactor it in order to sleep at night. King says product versus quality. Exactly. Product versus quality. I like that. Exactly it. Raid, what's up? Instantaneous challenge. Hi. King says spaghetti and meatball code served with garlic project managers. Yum. You're making me hungry, man. GTD says building software so complex that you don't even know. Story of life. Totally. Yeah. Let me check my notes here because there's a few other things that are just... Okay. So also, this article was focusing on the apocalypse, but the other story that the author weaved in was about the small group of programmers, vocal programmers, who give talks, who are well known, etc., and want to do things differently. So there's this guy, his name is Andrew, perhaps. Let's see. And actually his video where he suggests a new paradigm, a new way of doing things is on YouTube. This is one of the screenshots from it. What's his name? Andrew, right? Sorry, developers. I don't have bookmarks on this article. Let's see. Brett Victor. Okay. So Brett Victor has a few videos on YouTube, and he talks about doing programming a little differently. And the video is called Inventing on Principle. Paradoodly do, could you find that video, Inventing on Principle? The talk is a few years old, but it's really interesting. And he gives a demonstration of how to think differently in terms of designing a program. This is the example he gave. This is a GIF from the video, but basically he's adjusting the Y velocity and it's responding in real time. And what he was trying to do in the video was to get his little Mario character, I know it's probably hard to see, but he's trying to get his Mario character to jump on this turtle and then fit through into this little teeny treasure space. I'm assuming there's some sort of goodie past this frame. So he was playing with these axes and trying to get his character to the proper velocity to fit in. And he couldn't do it. So his character kept jumping up super high, and then he adjusted the velocity. The character jumped right into the waterfall. And so he said, no, this is not an efficient way of doing this. Because he was like testing and reloading every time he changed the velocity. So the character would fall down every time, and it was just like so familiar because we do these things, we save and reload, or we save and hot reload, and it's just such a process. So what he did, he said, how about this? What if I enabled something? What if I enabled playback on this scenario? And I was able to find a trail of his velocity. So as you can see, this gray thing is like the velocity. And right now what he's doing is that he's using he's using time complexity, time and space to his advantage. And he recorded the actions of Mario the first couple times where he jumped. And now that that's been imprinted, he turned on this feature and he's able to adjust it just so, you're not going to see it in the GIF because it's just a loop, but in the video he adjusts it so that Mario is able to slip right in this little treasure cove. Instead of just like mentally saying, okay, it's somewhere between 39 and 90. Okay, it's somewhere between 60 and 80. Now it's between somewhere 62 and 70. Instead of doing that incremental thing like programming in your head, as I talked about earlier in this article, he maximized time, the time and space, and then he tweaked it so he could fit the Mario character right in there. And it was so much more efficient. There's that play button I was talking about, the playback that he was using. So that was pretty cool. But then I thought, well, isn't that what machine learning is doing? Couldn't we just train this Mario to jump in here in a more efficient manner? Like, let's say our first try at getting him in here with the velocity landed up here, and then we had another data point down here, and then we defined our target data point as like right here. Like, see, I've never really messed with machine learning, so I'm probably sounding pretty ignorant. But for my machine learning people, Dr. Candace, I'm looking at you. Could machine learning be more efficient in this situation as far as creating a model? As far as saying, how could you train your model efficiently to tell the program that you want Mario to jump here? Or anybody who has experience with machine learning and artificial intelligence. So that was something that was not touched upon in this article. The role of machine learning, which is absolutely exploding right now, and it has been for the past few years. How does machine learning come into play with all this? If we have a 20 million line code base, which is increasingly common, these million-plus line code bases are increasingly common. When we see these code bases, how can machine learning models help us? Aside from trivial things, how can they respond, and how can we train models to respond with that elasticity, if that's even a word? I don't know. I just say what I say what I want. How do they respond with that swiftness and that elastic nature when humans are bringing forth problems and combinations of problems that have never been seen before? That was another interesting thing too about this article, is that when we hear about, let me consult my notes here because the quote was good. Let's see. Let's see. This is what it was. This was a great quote. Someone in here was quoted as saying this: human intuition is poor at estimating the true probability of supposedly extremely rare combinations of events in systems operating at a scale of millions of requests per second. I thought that was a great quote, and that's absolutely something we really don't think about all that often. When a million things are literally happening, 1 million things are happening per second, the rarity of an event is reduced. In other words, it becomes more probable. So let's take, for example, the Powerball. If the Powerball computers, let's see, how can we even illustrate this? If a Powerball guessing machine is going to be estimating the winning Powerball combination, if it's computing 1 million possibilities of numbers per second, it has a higher probability of winning the Powerball than a computer that is estimating 10 Powerball possibilities per second. And I think that the human bias is that we forget how the actual computing power of machines. They work so quickly. They generate this data so fast, lightning fast. And there are literally millions of things happening per second. Back in the day, like I find old school networking really interesting. So back in the day with networking, collisions happened all the time. We had data coming from what do they used to call it? Dumb terminal. We have data coming from dumb terminal A. We have data coming from dumb terminal B, or not data, but input, going to the mainframe. And then we see these collisions. The early days of networking was an absolute mess. And fortunately, we've evolved over that time. But we're still seeing a lot of messes. We're still seeing a lot of things that are colliding. because these processes are happening so quickly, we haven't tested for every single possibility. It's not possible in the current way we're doing things. So whether we're working at a digital agency, like I said, doing WordPress stuff, like you can't even predict the nature of a single WordPress instance with your 100 users per day. There's always some weird bug that's happening that hasn't been seen. And so the real apocalypse is coming, according to this article, with critical industries, again, like medical, aviation, transportation, emergency broadcast systems, and so on. One thing I wish they would have had in this article in Atlantic, a lot of magazines don't allow comments. I can see why, because they're just a total wreck. But also, sometimes people have some really good insight. So I wish the comment section existed. This is like the comment section. This live stream is the comment section of this article. So going back to the machine learning thing, they don't talk about it at all and what kind of role it might play in our jobs as software developers. So let's go back to this Visual Studio thing. This is an interesting bit. Chris Granger, who had worked at Microsoft on Visual Studio, was inspired. Within days of seeing a video of Victor's talk, he built a prototype of a new programming environment. You guys are going to like this. This is directly related to us. Its key capability was that it would give you instant feedback on your program's behavior. You'd see what your system was doing right next to the code that controlled it. It was like taking off a blindfold. Granger called the project Light Table. Now, correct me if I am wrong, but I think Swift, what you use to build iOS apps, implements Light Table. We got any iOS developers out there? Let me know, because I know there was a direct link to, if it wasn't Light Table, it was something else in this article that was talking about different paradigms and different ideas for designing our code better. And I know for a fact it was Swift that it did incorporate one of these designs, one of these prototype programming environments. Let's see. So they also talk about the FAA. And anyone who has ever worked for a government agency knows that paperwork is king. So it was interesting too, because with these FAA, with onboard software on a plane or any type of anything in aviation, every line of code has to have its own documentation. So what I mean by that is, let me go to my notes again. This is a quote from the article. The FAA is fanatical about software safety. The agency mandates that every requirement for a piece of safety-critical software be traceable to the lines of code that implement it, and vice versa. So every time a line of code changes, it must be retraced to the corresponding requirement in the design document, and you must be able to demonstrate that the code actually satisfies the requirement. The idea is that if something goes wrong, you're able to figure out why. The practice brings order and accountability to large code bases. I love this idea, but you know what? It takes a long time, and it will never fly in for-profit. A for-profit industry that doesn't have government oversight will never happen. It just takes too long. And the sad part is, for a lot of these industries, and this is just the way it is, that these catastrophic failures have been accounted for financially. What I'm saying is, companies know that software in their machines, in their computers, in their whatevers, is going to break, it's going to cause injury, it's going to cause loss of life. And they've accounted for that. And rather than spend X amount of months trying to perfect it, they go live with it and prove that, in 99.9999% of cases, that it's good to go. I'm not assigning any emotional attachment to that statement. That's just how businesses work. And it's interesting too, because as a society, we have, everything has software built into it, developers, everything. Our everything. You can't look around and not see it. And it's interesting to see where in 10 years this is going. because from a purely technical standpoint, we also have some really interesting things happening too. I am so excited for WebAssembly, but what is that going to do to our code bases? What is it going to do to our technical community when we have 20 people with 20 different programming languages working on the same project? Is that going to be a thing? If it is, how are we going to deal with that? Fortunately, as humans, we can adapt very easily. But this is what the point I was getting at. As we're getting more technical, I think we're also becoming less risk. We're becoming more risk averse. We see the numbers, we see the failures. We're like, oh my goodness, 0.1% of these users could not power on their machine. Or we see a review on Amazon for a computer that's 1 star, when statistically, that's like, 0.5% of people who had a problem with that computer. The squeaky wheel gets the grease. And so there is I guess what I'm saying is reading about these things and hearing these stories through the media, whether it's through a blog, through social media, through wherever, a newspaper, TV, wherever, any type of old media, new media. When we hear these shocking stories, for a lot of times, they're outliers. And we've become so... I think we're more just risk averse as a society because we rely on computers to take care of us, and computers have made society safer in a lot of ways. The old style of cars, they're cool. Old school cars are awesome, but they're also dangerous. And we have things built into our vehicles that do rely on software to keep us safe. The Toyota acceleration problem was a big problem. So that's an exception to my statement, but I think a lot of times the stories we hear they're outliers, and that's important to remember. They're not common, and the goal is to keep them very uncommon. But we have to accept, as a society, there is a risk to every piece of software that we publish, to every line of code that we write. There is going to be an effect. And sometimes it's not going to be a positive one. And that's just something we have to work with. We always want to improve. We always want to refactor, make it better. But there is going to be nothing is 100%. Nothing is 100% guaranteed, 100% safe or effective or efficient. But we're going for it. But it's just not possible because humans are imperfect, and as of right now, we write the software. Let's go to the comments. Let's see, Candace Leach. Yes, Candace is laying it down about machine learning here. Let's go up here. This is great. She says deep Q learning. Interesting. GTD says languages and frameworks have gotten so complex that it is practically impossible to keep it all in your head. Also, the same is true of most commercial software. Andrew says, I need to look into machine learning to properly place and composite logos on images of garments, but I don't even know where to start. Candace says, in reinforcement learning, the model, called the agent, interacts with its environment by choosing from a set of possible actions, action space, in each state of the environment that cause either positive or negative rewards from the environment. Okay, interesting. Thank you for adding that. Yeah, she says, the further we go, the more information the agent needs to save and process every given step it takes, and the more rewards it gets, the better the AI will perform. Interesting. Cool. Thanks for adding that. And that's just an area that is really exciting right now. We've seen, don't get me wrong, the models are only as good as as their inputs. And some of these models are thoroughly unvetted, but other models we've been able to learn a lot from. So that is something that I think is going to be interesting. And we're going to see, this is the thing too, developers, we're going to see more of these huge problems. And when your team tells your boss they don't know how to fix it, then what? Because it's one thing if the YouTube algorithm stops working. There's going to be like 3 people losing sleep from that. The rest of us are just going to go on with our lives and find a way around it. But when it's your 911 call that's not going through, it's your ambulance that's not coming for your loved one, and it's your plane that's crashing, you're going to want to hope that somebody knows how to save the day or at least save your life. And that's really, I think, the thing that we should be most concerned about. Preserving life and limb. And as machine learning, and not just machine learning, but as code gets into more of these medical devices and stuff, hacking has becoming it's a huge problem. It's a huge problem. And these devices are coming into, at least the United States, they're spy gear. It's spy gear. It's spy gear. They're unsecured. They're coming from dubious manufacturers, and they're ending up in sensitive environments, not just healthcare. But it's happening, and I mean this is a really pressing issue, and this is where this coming software apocalypse kind of wakes me up and kind of rings my bells, because I'm seeing it here and there as well. I'm seeing the trickles of no goodness starting to happen with this software and hardware. Security is a huge thing. We have a security shortage. We need more cybersecurity professionals, in my opinion, than we do software developers. And again, this is another for-profit thing that the Experian data leak, or who was the credit union, TransUnion? I don't remember which one it was. You know, it could have been prevented. These things can be prevented, but the companies bet that they won't. It's all a numbers game. And if it's cheaper to place that bet and hope it doesn't happen, then that's what's going to happen. Threat mitigation is just not pressing for a lot of companies with sensitive data. And that's scary. Listen, it's scary because my identity was stolen. And it happens to so many people that I know. Some bozo, and I shared this in another stream. Thankfully, it was just this one thing. Some bozo stole my details and opened up a dang Comcast account in a state I have never even visited. I was in the military. I was enlisted at the time, and there was no possible way I could have had service there. And it was on my thrown on my credit report. I couldn't get it taken off. That's a small inconvenience relative to the 911 grid going down or like a nuclear power plant stopping, but it's real to me, and it happened to me, and it sucked. It was a violation. I have no idea. I'm good with my details. I don't click on sketchy links. You know, it could have happened anywhere. It could have happened on a card. It could have been a card skimming thing where they somehow mapped my card to my details. It could have been one of these credit agencies. It could have been any place where they require your personal information. So that's a big thing too. If it's anything, if there's a coming software apocalypse, it's with the security aspect, in my opinion. The other thing, what was the other interesting thing down here? So the other thing I found interesting about this article is that nowhere does it suggest that we take a step back. Nowhere does it suggest that we start writing less code. Or rather, nowhere does it suggest that we start writing simpler programs, more modular programs, rather than these massive code bases that nobody understands. How could we implement that? I mean, that it seems like something that would be more sane, right? So, problem statement. Software is too massive, there's too many lines of code, and programmers don't know how it works. So my solution statement would be write less software. But we don't. Especially the American-centric attitude is just more, right? More. No, less. There are some things that we are doing worse nowadays with software than we were back in the 30s and 40s. And there's this magical thinking that a developer is going to fix everything. How many times have you, I've seen this so many times. I've seen this so many times with businesses or people with a business idea. Before they even have their business plan, they say, I need a developer. You need a developer for what? Well, for the code, for the app. Like, okay, what app? What code? And some people almost worship code and software as this magic pill, as this big moneymaker. Guys, software is also a big money loser. Most software startups fail. All this venture capital, poof. A lot of that venture capital is never seen again. Most software companies fail. Most ideas fail. Most code fails, like permanently. Like permanently. This server has been redirected to hell permanently. And so there's this idea that we need more developers to build more things, more code. You know, I think in my opinion, we need to build less of it and make it more modular. Now, granted, I have never worked in a mission critical field. So I don't even know if that's possible or if that's even a good idea. But just speaking from my own enterprise experience, speaking from what I do with my contracts and freelancing and stuff, when I work on a code base, one of the biggest problems I get into is that it's spaghetti code and it's not organized. And the software program is just too massive, and it exceeds the requirements that are needed to solve the problem. So that's just my 2 cents. Let's see what other people are saying. Reading Rambo says switch to procedural. I love procedural programming. Let's see. King says corporate mentality is asking, can you improve their classic ASP pages? Candace says, I know the feeling. I was in Iraq when someone opened an account with Comcast in my name. So, like, was that a thing? Like, I'll never get past it. I can't. The audacity, just like, and them still not taking it off my credit report. I just can't believe it. After proving I had no way of even physically being in that state. Reading Rambo, I love your frickin' username. That is so funny. Reading Rambo says, web dev is taught in business schools now. It's assumed you know some code to do some of it on your own. Yeah, that's interesting too. Because in this article, let's go down here. So talking more about solutions to these massive code-based problems, right? They're talking about this thing called TLA+. TLA Plus was developed by one of these old school guys. I think he's like in his late 70s, early 80s. I forgot his name already, but he developed this decades ago. And TLA Plus is a formal spec language developed by Leslie Lamport, used to design, model, document, and verify programs. And so I don't know anything about it because I've never heard of it. Only from what I read in the article. But TLA Plus, you use it for modeling programs and systems. And one of the things they mentioned in the article is that one of these like woke developers who's trying to save software from this impending apocalypse is that, so we worked at Amazon, he was a tech lead or something, and he discovered TLA Plus. And he found out that while TLA Plus could really help with design errors, with fixing design errors, most developers on his team at Amazon were opposed to it because it's based on mathematics. That the ivory tower, the old school 70s MIT style of programming. Despite the fact that TLA Plus has shown promise in certain agencies when they're dealing with large code bases. So there's actually a GitHub repo for TLA Plus, and as you might expect, it's not exactly as popular as Vue or Svelte. Let's go here, TLA Plus. TLA Plus right now, 53 watchers, but used at a place like Amazon. but probably only because the person who worked there is I don't want to call him a visionary, but he had an idea to do something a little more sustainable and maintainable with his code base. TLC is an explicit TLC. I thought it was TLA. Okay, TLC is an explicit state model checker for specs written in TLA+. The TLA+ toolbox is an IDE. I'm actually interested in seeing the syntax. I think it might be on this guy's page, but I don't remember. Let's see. TLA+ models are usually called specifications. They are called models in this introduction. Click here for an example of an algorithm written in +cal. So the gist of this TLA+ is that some companies, now a very, 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 very small amount of companies, have tried TLA+ to try and solve their design problems, to try and prevent them from going over the edge when it comes to creating software that developers don't understand. So let's check out some examples here. This is an algorithm written in +cal. So as expected, this is pretty old school. This example is Peterson's mutual exclusion algorithm. Here is the +cal code. To specify concurrent algorithm, you must say what the atomic operations are in +cal. The code from one label to the next is executed atomically, and so on. Yeah, not quite something your typical Java or JavaScript developer is going to be magnetized to right out of the box, right? This is some old school stuff. And unfortunately, a lot of these things that were developed decades ago, they're just not gonna happen. This is a new crop of developers. Most people did not major in math because back in the day, back in the 60s, 70s, even previous eras, there were a lot of math majors. These people were actual scientists. They wore frickin' white lab coats, and the computers were the sizes of refrigerators. They were scientists. And so math was, because there was less abstraction. They didn't have JavaScript. They were working in binary and assembly language. They were engineers working so close to the chip that they didn't have this distance. And I think just in general, that is a big problem that we do have in modern day software development, is that things have been so abstracted that we can't possibly make a mental model of what is actually happening when we write this stuff. Even a 200-line simple React app. There is so much going on. And a lot of people back in the day had electrical engineering degrees because there was such a connection between there was such an integration with hardware and software and the user and the creator and the programmer who was programming these things. They needed to know about electronics and how to engineer electronics. There was one person I interviewed. I actually did this interview last year. I interviewed college graduates who work in software development. Candace was in that article. Hey, Paradoodly Do, can you go to Medium on my account and try and find that article where I interviewed coding college grads who are software developers? There's this one person, her name was Script Queen, and she had a very interesting degree. It was in it was some engineering degree that incorporated electronics. And those types of engineers you see less and less of. But I mean, I really think this kind of stuff, I'm not saying we should all go write zeros and ones or and like become one with the laptop, become one. I'm not saying that at all. What I am saying is that we're facing more problems because these things are abstracted and we have to compute, just like this article mentioned, we're computing more in our head. And instead of solving problems directly, we're feeding instructions into a computer. So the abstraction there is so, it's so disconnected. It's so disconnected from what we're used to when it comes to physical problem solving, you know? With software, it's invisible, somewhat. Let's go to the comments here. Gabe the 5th over 3 says, times pi. I love it. Gave the fifth over 3 times pi says, also, old code had memory limitations at times. No doubt. No doubt. I mean, I referenced this last live stream or a couple of live streams ago. The NASA museum outside of Houston, Texas, they had these aircraft, spacecraft, orbit craft that ran on less tech than our smartphones. Like, it's mind-blowing. It's mind-blowing what people were engineering in the 50s, 60s, 70s, and 80s. Especially though in the 60s and 70s, where things were almost like, it was almost like just a digital analog version. What they were working with was so limiting. And I mean, that could be something too that we're facing, is that we don't have to be as creative. Because we have these tools, because we have the unlimited space, I mean, we're not forced to get creative. We're not forced to get as creative because we don't have those limitations. The benefit of not having those limitations is that we can build bigger and better things. Well, bigger, maybe not necessarily better, but you're right. There were severe limitations relative to today, back in the 60s and 70s. It's just mind-blowing. GTD says, no non-tech company actually practices TDD unless they're government regulated. Yeah, that's a great point. TDD and in these different things, agile development, some of these newer things like the Scrum Master, PEEPs, and all this stuff, they're great. Like, these are great ideas in theory, but a lot of companies just aren't doing it. Why would we appoint a Scrum Master? Why would we start doing this kind of development when we have something in place and we need a product by next week and this current system is already working? It's really hard to convince stakeholders to improve their process if they're already making money as a software developer. So, yeah. Let's see the comments. Treasure Rose, what's up? Jacob Mitchell. Should we learn TLA Plus? Just join the stream. Oh, heck no. No, not at all. I'm going to be adding timestamps to this live stream because there's just so much to ponder. TLA Plus is, they say it's not hard to learn, but it is. It is, because maybe it's not hard to learn for someone with a degree in mathematics or something, or been doing development for quite some years, engineering for quite some years, but no. TLA Plus is not on my to learn list for anyone on this channel, or anyone in general, actually. Andrew Weller says Scrum is a secondary skill, not a primary. Yeah, good point. But I think the bigger point I was trying to make was that companies just aren't willing to invest with new ideas, and at times new personnel. So I mean, most times if not all times, you're appointing like a really good communicator as the Scrum Master, or someone who has previous experience with it, who already is on the team. But trying to go from like waterfall to agile development in a business, and just trying to make things more efficient. I think that was probably my biggest point. A lot of companies just don't see the light when we try to explain to them that different ways of doing things might not just make our jobs better, but make the company more money. Randy Miller, 8K was a thing in the 70s. Totally. My business analyst is also our Scrum Master and project manager, says Rick Cable. Sammy Turner says that formalism had a for-all quantifier and a membership relation. This will not take off. Candace Leach says, especially with a tight deadline, don't have enough time to test. Yeah. Technomancer says coding culture in general is too quick to jump on to the new and shiny, focusing on quick and dirty, where in fact, we should be taking pause to understand what we're building. I mean, isn't that every developer's dream? Just to have a day where we can think about our programs. Yeah, and I don't know. Working a 9 to 5 is kind of a dream killer. If you go into the industry thinking that you're going to be creating life-changing software, because we have these dreams, but then we hit the reality of the 9 to 5, where the deadline is king. The deadline takes the priority. And I see these talks all the time. I see these motivational speeches, whether in person or on YouTube or on like on a TED Talk or whatever, about making software better. Software is not going to get any better. Just straight up, it's not going to get any better. It's going to get worse. There's going to be more spaghetti code. It's going to be more unmaintainable because we're consolidating code bases. We're consolidating services. We're building things that are a complete waste of time. And it's just going to get worse before it gets better. IMHO. Unless you're a really, not only forward-thinking company, but also don't have a lot of team members. If you're like I don't know what the word is. If you're able to pivot easily as a startup or something, you have like 10 people on your team, you're able, and you have a lot of venture capital, and you're able to test these things, test the better processes, and take some time to organize your code and take a few days to have the team think about it and just reflect on it. Like, wouldn't that be something? Having a job where you can reflect on your code for a day or two. I mean, those are some of the days where I've written the best lines of code of my life, where I rest on it. And these are all personal projects, mind you, because again, deadlines in the real world. But when I'm thinking about my project and I come across a problem, I'll take a day or two break and just let my mind work while my brain is offline. And then I'll come back and I will be writing some killer software, the best. But that just isn't. It's just a luxury that we dream of when we're on the job. And so, I mean, I don't want to sound like a negative Nancy about companies not being able to improve their processes, but I just don't see software development getting any better in most companies. I just don't see it. Show me the data, show me the stats, and maybe I'll take a deeper look at it. But as is right now, I just don't see it. King says corporate doesn't allow creativity. Exactly. Bingo. Yeah, and that's a wake-up call too for a lot of developers, especially those of us in creative. If we're creative people and are working as a front-end developer and have our eyes on design and stuff, the creativity is encouraged, but with very strict boundaries and very strict parameters. You know, people, I remember just starting a lot of projects, for-profit projects with these wild ideas, like just killer ideas, and the client's like, yeah, that's not going to work. You know, working on like an idea for 3 or 4 hours, and then just the client 3 seconds later, that kind of squint in their eye, but just almost imperceptible, and they're saying, yeah, that's not going to work. I had a great idea. But yeah, for corporate, they have all that stuff's already planned out with what they need. As software developers, we are problem solving in corporate, but we're also solving their problems in certain ways that they prefer. Thanks for joining, everyone. If you're just tuning in, we're talking about the software apocalypse, the upcoming software apocalypse, which is more pressing in some industries than others, especially mission critical industries, or maybe just critical industries, healthcare, emergency response systems, transportation, lots of others I'm missing, I'm sure. Security, energy, those are big ones we didn't even talk about, but the energy industry is a huge one too. Cybersecurity, securing these resources, so much. And again, shout out to GTD and my patrons and YouTube channel members who make these types of videos possible under normal circumstances. There just isn't enough demand to talk about these topics, but I love talking about this stuff because there's so much to talk about. This is our future. This is our future, and talking about it makes me feel a little less depressed. So thanks, GTD, for the great topic and for sharing this article. Rick Cable says, I'm lucky. I've been able to invent a few apps that the businesses use. I have a reputation for inventing stuff, so I get a lot of leash sometimes. That's good. That's good news. Andrew Weller, you can be creative in corp if your team is small enough. I have to do design at times, and I'm free to use whatever tool set I'd like. Good point. It does, a lot of it is so dependent on the size of your company and your mission of the company. GTD says, I don't think you can be too creative in large enterprise code bases. Absolutely. Sometimes devs go too far off the leash and into time sinks. Yeah, I mean, one of the things I'm so glad I entered enterprise. The reason I did enterprise in the first place was mostly as a kind of like a researcher. Like, I wanted the experience, but I knew going in I wasn't going to stay in a 9 to 5. That was never my goal. Early on, I had decided that. But first of all, I wanted to see if I can get a job. Because if I had convinced myself I was good at programming, I was good enough, then I needed to prove it. Other people needed to validate my skills in order for me to say, you know what, I am a web developer, I am a software developer, I can do this. Someone took a chance on me. I was getting callbacks, interviews, job offers, and I took a job offer. And so that was a validation for me. To know that I wasn't just inventing things about me being a software developer. I could actually do this stuff, or at least convince someone I could. So my time spent in enterprise, I was adding value, but I was also writing, I was taking adamant notes. I was adamantly taking notes, robust notes about everything, because it is such a different world. Everything, the communication, the power structure, the tasks you're given, the time allotment, the deadlines, the amount you're getting paid, your job duties, the interpersonal communication between team members and teams. Everything to me was so fascinating. And so I consider myself, I was an embedded software developer at that time. I had embedded myself like a journalist, but just taking notes just for myself so I could bring them to my own business and also perhaps use them for sharing with others. And so I spent just enough time in enterprise to realize everything I wanted to realize and take notes on everything I wanted to take notes on. And I don't regret one day of it. It's such a different world than freelancing. It is a completely different world than building projects on your own. And once you get that first dev job, it's going to change your life. If you're an aspiring or new developer looking at that first job, oh my gosh, it's going to change your life in so many ways. It's great. It's a great feeling getting that first paycheck and feeling that validation, like, oh, I actually am adding value to this company. Sweet. So yeah, it is 5:44. We're going to take a look at a few more comments. Thanks everyone for tuning in today. If you've enjoyed today's conversation, please hit that like button. Shout out to GTD for the great topic. Shout out to Dr. Candice for giving us that knowledge, excuse me, on machine learning, and everyone else about corporate development, these huge code bases, everything else. Rebecca says, we went from waterfall to agile a couple years ago. It was a hard transition to make. Rebecca, I would love to ask you more questions about that. If you're able to, if you're still on the chat, let me just ask you, what do you think was the most difficult thing about that transition? And second, first of all, whose idea was it to go from waterfall to agile? And also, what do you think the most difficult thing was overall? If you're still in the chat and are comfortable answering that, I would love to hear it. Because those types of transitions are so painful. And you're not getting paid more for it. It's like, man, at least if you're going to give me this mental and emotional turmoil of making this huge change, can I get some kind of, endangerment pay or something? Rebecca says, I couldn't do freelance. I'm so shy and I can't sell anything. I hate talking to people. I hear you. Freelancing is tough for a lot of developers who are really shy. If you have zero interest in it, I'm not going to try and sell it to you. Freelancing, because it's definitely not for everyone. But if you can get a small network of friends and family giving you referrals, sometimes that can make it a lot easier. Talking to a stranger and trying to sell yourself is like so weird, right? Like, I still talking to people is tough, especially strangers. It's just like, The dynamic is odd. It's just not a natural thing. But you know, if you do decide to experiment with it, one tip I can give is that starting with friends and family is so much easier. It's so much less stressful. Rebecca says the decision was made before I was hired. Yeah, that's fun too. I say sarcastically, coming into a company as they're making a big transition like that, whether it's a practice or changing something like a different framework, or just updating the code base as you're training into that new job. When I came into enterprise, my first enterprise job, they were transitioning from no frameworks to 4 of them. So it was like some of these code bases had 0 frameworks. Some of them had old frameworks. And then the goal of the senior developer was to update everything to Vue or Angular or the current version of Knockout. OMG, it was such a mess. By the way, this is a good time for a product placement. I talk about my corporate endeavors in Real Tough Software. This is my 4th book, my 4th #1 book, Real Tough Software, by the one, the only, this speaking entity on your screen right now. Thanks everyone for your support on buying that book. I talk about my coding journey, my time in enterprise development, some of my processes, how I learned, what I studied. Yeah, and just kind of, I don't want to call it a memoir. It's a little too early for one of those, but really just describing my process for finding a job and what I experienced on the job and what I'm doing nowadays. Reading Rambo, misanthropes are drawn to coding. Yeah, they kind of treat you like a hit and run for their profits. I wish the employees with Angular a patient day. Treasure Rose, thank you everyone for tuning in to tonight's stream. Great topic, great conversation, lots to think about. Rebecca was talking about the transition from Agile or Waterfall to Agile. She said the hardest thing, I think, just getting everyone on board. The decision was made before, but we didn't switch until 6 months after. Yeah, developers, that's another thing. Teams are messy. We're people. We don't like each other sometimes. We come in, we're having a bad day. And not only that, we're creatures of habit. So if we're doing waterfall development, Agile is not something we want to be thinking about if we're comfortable with waterfall. And getting people, that's right, just getting that mind share going, it's tough. Any type of technical decision. And especially with people when we, like, you know, all of us fangirl and fanboy over some of these technologies. And you have fanboys on the team. You have people who don't want to change at all. Who was that woman in NASA in the 60s and 70s? Margaret, oh, I can see her picture perfectly. One of my old schoolers might know who I'm talking about. Her name was Margaret. She worked at NASA and was responsible for a lot of cool things at NASA. She was talking about the switch from going from binary to assembly. And she said people were just like, people were very adamant about not switching to something a little more readable. People were holding on. People were clutching to their 0s and 1s and saying, you'll have to take these 0s and 1s from my cold, dead hands before I do something different, before I try a language that is slightly more human and slightly more accessible. People are very hesitant to change, and that is just something that it's a human trait. A lot of us, most of us, have that trait, and making those changes in enterprise, it seems like a simple thing, but it never is. Developers, thanks for tuning in tonight. It was a great live stream as usual. I hope you enjoyed tonight's chat. Relax, it's only a software apocalypse. Take it easy. We're going to be doing another live stream tomorrow or a premiere. I haven't quite decided yet, but we'll be back. As always, continue the chat in the Discord. Paradoodly do, or Sarah O, would you please kindly pop that Discord link? Have a great evening, great rest of tomorrow, and I will see you in the next live stream. Peace out.